Greetings! Today, I'll show you guys how to speed up Python programs by using PyPy. PyPy is an implementation of Python that runs faster because it uses a just-in-time compiler. We'll first start off by installing PyPy, and then running through an example which compares PyPy to regular Python. Let's get started. So the first step is to install. So let's do that. Here I'm going to select Markdown and type install PyPy. All right, so what I want to first do is I want to download PyPy, and I have the URL that I took from the website. So I'll take that and put that here, and I'm going to do curl. Some people call it curl, some people call this curl. I like to call it curl. So I'm going to do curl, and I'm going to use the URL from the website for the PyPy tar file. There it is. And then I want to save this as the name, so call this output pypy.tar.bz2. So what this is doing is it's downloading PyPy from this particular resource on PyPy or python.org, I should say. And then it's renaming this as pypy.tar.bz2. And because this is a Jupyter notebook, I have to prefix this command with an exclamation mark. If I don't, Jupyter notebook won't know what to do with this. All right, so once I have that downloaded, the next step is to unzip or untar that file. So we'll do unzip, and I'm going to use tar-xf. We called this, when we downloaded the file, we downloaded this as this. So we're going to refer to that same name. So pypy.tar.bz2. Perfect. So once we are there, we then have the contents of this folder or this file have been unzipped, right? So the contents have been unzipped. We want to keep those contents, but we're still going to have the folder itself, and we don't need this tar file anymore. So what I want to do at this point is I want to clean up my file system. So I'm going to clean it up by removing that original tar file. So I'll do rm for remove and star.tar.bz2. So this is saying that within this folder that we're currently located, remove any tar files. And that's what this is doing. All right, so once we're here, the next thing that we want to do is we want to rename the folder. And this is more so for convenience. Once we have extracted the contents of this folder here, we will end up with a file or folder, I should say, that has this particular name. It should be called PyPy 3.9-v7 and so forth. So I'm going to rename this to make it easier for me to handle, and I want to rename this as PyPy. So I'll do call this rename folder, and I'm going to copy this, and we'll do mv for move. Use that particular name, which should be the contents once it's extracted from our tar file, and then rename this as PyPy. Perfect, that should work. All right, so at this point, I should have a folder in my system called PyPy, and this folder is actually the folder that contains the PyPy executable, right? And that means you can do everything that you can do with Python. One of the things that we do need to do is to install pip. Out of the box, it's missing pip. So I'm going to install pip into PyPy. And in order to do that, put install pip into PyPy. In order to do that, I'm going to reference the PyPy executable. So I'll do /pypy. So this is saying within the folder called PyPy, I want to go into the bin folder. So this contains all those binaries. And then I want to reference the PyPy interpreter. So again, whenever you see PyPy, just think Python, right? PyPy equals Python. So this is using that Python executable or interpreter. And I'm going to call this command, it's -m ensure pip. And again, all this does is download pip for this Python instance. And let's see, what else do we need here? So just like how we had it for the very first step, all these commands, I have to prefix it with the exclamation mark. Otherwise, if I don't do that, then this Jupyter Notebook will not know that I want to run this as a command. It's going to get confused and think that this is Python code, but it's not. These are actual bash shell commands. All right, so this should be good. So I'm going to run this right now, and hopefully it works without any issue. So right now it's at this step, and it is currently downloading the tar file. All right, great. It's been downloaded here. Perfect, good. So, as we see here, it downloaded successfully. It created the file here, and then eventually it removed it because we had the cleanup step here. And then it did ensure pip, which installs pip to our PyPy Python instance. And that's what you see here. So I like to kind of double check things. I'm going to do a smoke test, which means we run this and see if any fires occur. What should happen is I should be able to access the Python instance, which is here. So let me go to a terminal, and I'll go to terminal here, and then we'll do we're going to cd into the notebook. So cd into notebooks and PyPy. Great. And then once we're here, I'm going to run the Python interpreter. So I'll do /PyPy, and then within that PyPy folder, we'll do PyPy, and perfect. So as you see here, when I ran that command, I see what we normally see when I run a Python interpreter, right? So I can type in commands here. I can do print foobar, and that's going to work. So everything that you can do in Python, you can do here. This is just really another implementation that happens to be faster. Okay, so let me go back to our Jupyter Notebook file. And then the next thing that I want to do here is I want to compare PyPy to regular Python, right? So one of the questions that you guys might be thinking is, okay, we've downloaded this and it works, but how fast is it? Or a better question is, how much faster is it in comparison to regular Python, right? So I'm going to answer that question right now. And we'll call this next section comparison. Or we can just say compare PyPy to NumPyPy. And when I say NumPyPy, I'm referring to the regular Python version. So let's see. The first thing that we're going to do is we're going to create a file here. So create file with contents. And over here, I'll just do a new. We'll call this file compare.py. Perfect. And in this file, we are going to import the timeit module. So the timeit module is used to test how fast your code runs. And that's exactly what we want to do. We want to test how fast our code is running. So I actually have it over here. And instead of typing the whole thing, I'm going to copy what I have. So again, we import the module. Here, what's happening is we are running the code, which is in the string here. We are running that 100,000 times, right? So the whole point of this is to really be able to see how fast this thing can work. So we're stress testing this. And 100,000 is enough iterations where you should notice a difference if there is a difference between the two implementations of Python. And then this very last step takes the time that is obtained and then prints that. The time that we obtained is going to be in seconds. Now going back to our Jupyter Notebook, we will create the file, and what I'm going to do here is I'm going to put the file just for historical purposes so I can refer to and create that by looking at this Jupyter Notebook. I'm going to uncomment this. Good. So once you have the file created, you can then run this. The first thing I'm going to do is run this with regular Python. So run with non-PyPy instance of Python. And in order to do so, we'll do Python, which is the regular Python that I have in this file system, and we'll do compare.py, and we will run this. So because this is being run as a shell command, I need to prefix this with the exclamation mark. All right, perfect. So when we ran this, it took about 1.17 seconds. I'm going to run this one more time just to make sure that that wasn't a fluke and see if this is repeatable. It should be. We should get about 1 second or so. All right, perfect. So as you see, running this with the Python interpreter, the non-PyPy Python interpreter, this is about 1 second. Now let's run the same code, but this time we're going to run with PyPy. So we'll do run with PyPy instance of Python. And we will do exclamation mark, and we're going to reference the Python version, which is installed here in our first step right here. So we have this exact one, which is here. And back that up. So we'll do PyPy, Python, and we'll run compare.py. And if we're correct, this should be faster. That is a noticeable difference. Instead of taking 1 second or so, it took about 0.2 of a second. So let's run this again. Great. So as you see here, the difference is quite significant. PyPy took about 0.2 of a second, and regular Python took 1 second. And based on our analysis, it appears that the PyPy version of Python is indeed faster.